H prime minus T0.
I don't know what A is, don't really need to know it, but I do have the ratio of A to B, which doesn't change because
We haven't changed the materials. Likewise,
all right, so this is, so I'm just going to adjust that. So this is 2 and a 2, and that's H prime. And this one up here, this is dealing with the heat exchange that's happening with an individual freezer, so it does not change at all. QC stays the same, TH is now TH, and the cold temperature, the freezers are still negative 13 degrees Celsius. QC, so this is Q. We now will adjust this. Those are primes. H prime is TH prime. Those stay the same. So we have B times TH prime minus TC over TC is equal to 2 times QC. Oops. That's what happens when I don't start from scratch. Let's adjust this. So QH prime minus QC is equal to 1/2 A TH prime minus T0. So QH prime is equal to QC plus 1/2 of that, and QC is, that's H prime. H prime. We go through the exact same process. We multiply times that, and so this becomes H prime minus C. This is H prime, H prime, H prime. Everything else is the same. The difference is we know what M is now. We're trying to figure out what is H prime. We're trying to figure out the temperature in the tent. And so we're trying to figure out what H prime is. So let's get rid of some of this other stuff. I've got H prime squared minus CH prime equals CH prime minus C squared plus 1/2 MC H prime minus 1/2 MC. Solving for H prime, it's a quadratic. Got a squared term there that's not going to cancel out with anything. Quadratic formula. Let's get everything over on the left-hand side. So I have H prime squared, and nothing else times it, plus H prime, and I will have negative 2C. So bring that over, and bring that one over, minus 1/2 MC plus C squared plus 1/2 MC. think I got all the terms there. So 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, that's right. Combine the CHs. Pythagorean theorem. H prime equals negative of that, so 2c plus 1/2, 2c, oops. Yeah, 2c plus 1/2 mc plus or minus the square root of that same thing, so 2c plus 1/2 mc squared minus 4 times 1 times this c squared plus 1/2 mc, all divided by 2. Now, we can simplify it some. I got that 2 down there, so I can factor a 4 out of this, and I can then divide everything by 2. Or I guess factor a square root of 4 out of that. So I end up with h prime equals, and there's a reason this was on the floor, c plus 1/4 mc plus or minus. I factor that square root of 4 out, and I am left with, I got c plus 1/4, and so square root c plus 1/4 mc squared. And over here, 4 is right there. So minus c squared plus 1/2 mc. And then I check just to make sure that didn't mess up somewhere there. So that's c plus 1/4 minus, and then over here I'll divide some stuff. So c plus 1/4 mc, and then the whole quantity squared, and then c squared plus 1/2 mc. Okay. You're going to get 2 solutions here. Which one do you pick? Well, let's run through a case. Gut feeling, plus or minus?
Plus.
Vote for plus.
Yeah, I agree.
Okay, let's find out. So if we unplug both freezers, so this is just a test to see plus or minus the square root, plus or minus the square root. If we unplug it, then I would expect everything to go to the outside temperature. All the heat would be generated to the environment, everything would be equal to TO. So therefore, H prime would be equal to 1 and it would be equal to C if we unplug the freezer. So I have 1 equals 1 plus m over 4 plus or minus the square root of, and then let's see what's inside here. If C goes to 1, we end up with, my discriminant becomes 1 plus m over 4 squared minus 1 plus 1/2 m. So that's 1 plus 1/2 m plus 1/16 m squared minus 1 minus 1/2 M. Those cancel out, those cancel out. What I'm left with is 1/16 M squared. So I'm left with 1 equals 1 plus M over 4 plus or minus the square root of this, which is just M over 4. Which one is going to give us a true statement here? Plus or minus?
Minus.
Yeah. And it ends up that negative is the correct answer. So we are left with that. And so C is still 260.15 over 273.15. That is still the value of C. M is the 0.753 there. Plug and chug. And what do you get for H prime? What'd you get?
I'm not sure which one's minus, but I ended up with 1.25 and 1.008.
The 1.00. How'd you get two answers? The plus or minus?
Yeah.
Okay, well, we know the negative is the correct one, so.
Sorry, that'd be actually 1.009.
All right, and that is the new hot temperature divided by the outside temperature. Oh, sorry, Benjamin, I'm just running with it. I probably should verify. I know it's gonna be a little bit more than 1.
Yeah, I'm getting a non-real result, so I'll probably just go. I think
got a
I'm
negative under the radical there.
messing up a parenthesis somewhere.
All right, well, for the sake of this, let's just assume that the factors, right? T naught is 273.15. So what's the new hot temperature? Everyone's talking about it.
275.61.
375.61.
275.
Yeah, 275. That makes more sense. And then minus 273.15.
2.46 degrees Celsius. Degrees Celsius.
So we can take it from a balmy 1 degree Celsius up to a sweltering 2.46 degrees Celsius. I probably should do different numbers also, so it's a little bit more dramatic. Anyway. With thermodynamics, I was hoping to get to that point. I have done it. Well, I'll do some things differently next time, which won't affect you at all. Questions? All right. Shifting mindset, fluids.